Hello guys, and welcome back to another episode of chemistry. All right, and today we are going to continue our study of the alkanes. In the last class, we talked about how to prepare alkanes. Okay, we saw a number of methods. Please commit them to your memory. Okay, and in this class, we're going to see the reactions of alkanes. Reactions of alkanes. Reactions of alkanes. All right. So, what type of reactions do alkanes undergo? All right. But before we continue talking about this, let us see a question from the O3 School JAMB app. All right. Note that this video tutorial is brought to you by the O3 School JAMB app. It is all you need to succeed in your exam. If you want to succeed and not succeed, okay, please download the O3 School JAMB app from Play Store immediately and start practicing your way to success. There are a lot of testimonies from last year's students. Your case will not be different, all right? Activation fee for that app is just a little token. Make the sacrifice, download the app, activate it, and start practicing. We're going to talk about the app later, but for now, let's see a question from the app. This is a 1995 question, number 42. It is being currently displayed on the screen right now. CHCl3, that is chloroform, plus Cl2, the product side, HCl plus tetrachloride. Okay, they say the reaction is an example of A, addition reaction, B, a substitution reaction, C, a chlorination reaction, D, a condensation reaction. All right, so when we're talking about the alkane profile, you're on the first introduction to alkanes, okay, we say that the alkanes undergo mostly substitution reactions, isn't it? All right, so I'm just giving you a hint. We're going to see this reaction, alkane, because alkanes or hydrocarbons react with with chlorine molecule under some certain condition, under bright light, especially diffused light, to give us what we call tetrachloride. Okay, it's a four-way reaction, four-step reaction to give you that tetrachloride. We're going to see that full reaction before the end of the class. So please stick with us. Go to Play Store right now, download the app, and start practicing. All right. Also, do not forget to like this video. Liking this video will make other students easily find this video. Do not forget to subscribe. Click on that red subscribe button so that whenever we publish a new video, you'll be among the first to see the video. All right. So please let us go to reactions of alkanes, and then at the end of the class, we'll come back to that question and some other questions from the O3 Schools JAMB app. Now, reactions of alkanes. Generally, alkanes are unreactive. They are unreactive. They do not like reacting with other substances, okay? And the reason for this is not far-fetched, okay? The reason for this is not far-fetched at all. And what is the reason? Should I give you some time to think about it? Yes, the reason is that they are saturated. Alkanes, they are what? Saturated. We've talked about what? Alkanes, what? Being saturated hydrocarbons. Okay, they are saturated with hydrogen. Okay, so they are full. So they do not see any reason to want to go into reactions. Okay, they do not have that affinity to just go into reactions. All right. So for you to be able to react with alkanes, okay, or react with hydrocarbons as such, as alkanes, you have to first of all break their bonds. Okay, and you know that they have a sigma bond. The sigma bond is a very, very strong bond. So you have to first of all break that bond, or you have to replace what some of the atoms or molecules that are attaching themselves to the hydrocarbon and replacing them with other ones. So it's usually very difficult for them to just go into reactions. Okay, but they do undergo some reactions we are going to look at right now. Okay, number one is combustion reaction. Combustion reaction, okay, or just say combustion. Okay, let us just say combustion. Okay, so they undergo combustion. Okay, they burn. Okay, so combustion is reaction with with oxygen. Okay, we're talking about combustion, talking about reaction with oxygen. Oxygen, that is O2. Okay, so alkanes undergo this reaction called combustion. Okay, they react with oxygen. Okay, they burn. Okay, and that is why we use them as fuels. Okay, the reason why we use them as fuels is because what they burn what easily. All hydrocarbons burn quite well. They burn quite well, and that is the main reason why we mostly use them as what? As fuels. Okay, so now let us see some of this reaction. And alkanes such as methane can what? React with oxygen. Okay, so in terms of this combustion, we can have complete combustion of the hydrocarbon, complete combustion of the hydrocarbon, and then we can also have incomplete combustion. Incomplete combustion. All right. So now, in the case of complete combustion, okay, what matters to us is not that the reaction is well balanced. What matters most to us is that the product that is formed is what? Is carbon dioxide and water. Okay, while in the case of incomplete combustion, all right, it means that what? Enough oxygen is not supplied for the complete combustion of the hydrocarbon. Okay, enough oxygen where there's limited oxygen. Okay, there's limited oxygen which is not enough to burn the hydrocarbon completely. And in that case, the product will be having maybe sometimes carbon and what? And water, or sometimes other case, or more dangerously, carbon monoxide and water. Okay, so in the case of what? Complete combustion, what matters to us is not that the equation is balanced. Okay, it is now left for us to decide what will be the product, whether we are going to have carbon and water, or what? Carbon monoxide and what? And water. So let's also see an example of what? Of such combustion with reactions. Let's see an example of complete combustion where, for example, methane CH4, all right, will react with oxygen O2, all right, because it's complete combustion. Our product will be what? Carbon dioxide and water. Okay, so we're going to have our product to be CO2 plus what? H2O. Of course, if you look at the reaction, definitely you should see that what? It is not what? Balanced. It is not balanced. If you do not know how to balance equation, go and watch our video tutorial on balancing of chemical equations. A full video has been dedicated to that on this channel. So please go and watch it and learn how to balance equations. Okay, so now here from this right hand side, how many carbon atoms are here? One carbon atom is here also. All right, so now let us see. On this other left hand side, how many hydrogen atoms are here? 4. But how many are here? Just 2. Okay, that means there's a deficit of what? 2 hydrogen atoms in this side. All right, so now oxygen. What about oxygen? Yes, 2 atoms here. Here there's 2. Okay, there's 2 atoms here, and then there's 1 here. 1 plus 2 is 3. So there are 3 atoms of oxygen here and 2 atoms of oxygen here. That means this right hand side has a deficit of what? Of 1 oxygen atom. So what do we now do to make it balanced? So we have to introduce some ratios. Okay, so now if we put 2 here, this will mean that what? We now have what? 4 hydrogen and 2 oxygen. Okay, and then plus this 2 oxygen, to now make it what? 4 oxygen all together. Okay, so if we also put 2 here, it will mean that what? We also have 4 oxygen here. All right, we have 1 carbon, 4 oxygen in this side, 4 oxygen on this side, 4 hydrogen on this side, 4 hydrogen on this side. This will now be our balanced equation. All right, so this is what? Methane, that is methane burning. This combustion of what? Of methane. Okay, when methane burns in here, we're going to have what? If it's a complete combustion, I'm going to have CO2 plus 2 H2O. All right, so let us see, for example, let us see ethane. So I'm going to have C2H6, then plus what now? O2, then to give us, since it's a case of complete combustion, I'm going to have CO2 plus 2H2O. Okay, sorry, not 2H2O plus H2O. All right, so we have not balanced. Let us check if it is balanced. It is not actually balanced. So just to save time, okay, let us introduce what? The ratios. There will be 3.5 oxygen here. Then of course here will be 2. Then here will be what? Will be 3. Then this equation will be balanced. Okay, but of course some people are easily not comfortable with having a fraction here, okay, a mixed fraction for that matter. Okay, so we can decide to make everything even by multiplying all through by 2. Multiply all through by 2, we're going to have 2C2H6, then plus what? 7O2, then plus 4CO2, then plus what? Plus times 2 is what? 6H2O. Okay, so this will be our balance equation. Whether you write this or you write this, it is still the same. Than what? Balance equations. Alright, so this is what happens in the case of complete combustion. But if, for example, It's a case of incomplete combustion. All right, incomplete combustion. That means there's no enough oxygen, okay, to burn the hydrocarbon completely. Then the products are going to be having the either carbon monoxide and water, or carbon and just water. The hydrocarbon may just burn to what? To leave what? The carbon, okay, and then that carbon that is left is usually what? Bright yellow. It usually have what? A bright yellow flame, a very bright yellow flame. Okay, all right, let us see the reaction. If you see, for example, we have methane, then plus what? O2. Because it's a case of incomplete combustion, we have C plus what? H2O. So let us balance this reaction. Is it balanced first of all? I don't think it is balanced. So let us balance. We have one carbon atom here, one carbon atom here. We have 4 hydrogen atoms here. We have just 2 here. Okay, so that means we can balance that. If you put 2 here, that hydrogen atom will be balanced. Okay, if you put 2 here, hydrogen will be balanced. We have 4 hydrogen, we have 2 oxygen. We have 2 oxygen. Carbon is balanced already. So this equation is already what? It's already balanced. So it is this carbon that we are given that usually what sooty. I don't know if you know soot. Okay, so those of you that have used lamp before, okay, lamp, that holding this lamp. So okay, if you raise the wick up, you see some very, very black, smooth, something like very black, like charcoal, but it's smooth, it's grounded, very fine and retuned. Okay, you see it falling off from the wick of the lamp. That is carbon soot. That forms as a result of what? Incomplete combustion. Okay, of what? Of the fuel. All right. So now, this carbon usually was sooty, and then it burns with what? A bright yellow flame. All right, so please just take note of that. But that happens in the case of what? Incomplete combustion. So that's what happens in combustion. Like I said, what matters most in the case of complete combustion is not that our equation is balanced, though, is the product of what? Of the reaction. Okay, for complete combustion, we always have carbon dioxide and water as products. But for incomplete combustion, we either have carbon and what? And water, or carbon monoxide and water. So let us see another reaction that is undergoes, and that was not far-fetched. That will be substitution reaction. Substitution reaction. So hydrocarbons like alkane, okay, they have the ability of swapping one of the hydrogen atom for what? For another molecule, for another atom. Okay, so they can swap. Substitution, they can substitute themselves. Okay, you know what happens in the football match when a player comes in for another player? Okay, so the person is actually replacing that person. Okay, it's actually replacing that water player. So they can replace what? Themselves with that hydrogen atom that they have. Okay, and replace it with another atom to come into the reaction. Okay, that is substitution reaction. Okay, let us see an example. Basically, first of all, it's important to know that alkanes, they burn very well. Okay, they are very good at burning. All right, but they are not very, very good with reacting with halogens. They are not so very good with reacting with halogens. All right. So now, but they can react with halogen under some certain conditions. Okay, if these conditions are right, okay, they can react with halogen. So they can react with halogen under what we call bright sunlight. Bright sunlight. Okay, they can react with halogen under very bright sunlight. Okay, for example, like the UV light. Okay, so they can react with what? With halogens under bright sunlight, like the UV light. Okay, and if this happens, substitution occurs. Okay, and then there's swapping, there's change, there's an exchange. Okay, let us see what happens. For example, if methane reacts with a bromine molecule, CH4 methane reacting with a bromine molecule, Br2, what will happen is that one of the hydrogen atom from the hydrocarbon will replace itself with what? Will attach itself to what? One of the bromine atom, okay, from the bromine molecule. All right, that is what happens. So let us see the product here will now be what now? I'm going to have CH. It was 4 before, it will now be 3. Br, okay, Br will replace itself, okay, but the hydrogen atom, it has lost one hydrogen atom. That remaining hydrogen atom, that H that remaining will now come here. Then the remaining Br that was here will now come here. Br. So this is what happens in terms of what? In the case of what? Of substitution. All right. So they will replace themselves. Okay. For example, if you have ethane, C2H6. Okay, reacting, for example, with chlorine, Cl2. What will happen is that what I'm going to have C2 instead of H6 now, I'm going to have what? H5 Cl. Then I'm not going to have what now? Plus what? Plus C, plus what? Sorry, plus HCl. This will be our what? Our product. Okay, it is important to know that, well, first of all, halogens are colored substances. Halogens are colored substances. Colored substances. Halogens are what? They are colored substances. Okay, but when this substitution occurs, okay, it changes what? It changes them to what? It changes the product is formed. It now becomes colorless. Initially, here they are colored. This is colored bromine, okay, but if it is what replacing itself, okay, if it's what substituting, undergoing that substitution reaction with what? With an alkane, what happens is that what? It loses what? That is coloredness. That is coloredness, and it becomes what? Colorless. Okay, so that is what happens in the swap. Whenever the swap occurs, the halogens, they lose their coloration, they lose their color. Okay, so this is just an example of what? Of substitution reaction that they undergo. Okay, we are going to see another substitution reaction, halogenation, where methane reacts with what? Reacts with chlorine in the presence of diffuse sunlight to give us that tetrachloride, which we saw in that question. So please go to the Play Store, download the OT School JAMB app. Like I say, it is all you need to succeed in your exam. It has all the past questions that you need. Okay, for all the past questions, you don't need to bother about past questions again. Also, has question start feature. In that question start feature, you can start for questions according to topics. And what's more is that we also have the UTME mock challenge. In this challenge, you compete with your mates. Get used to JAMB past question, get used to JAMB likely exam question, build your confidence toward the main exam, and keep smiling, waiting for you to tear down the exam. Okay, activation of this app is just what? A little token. Go to Play Store, download that app, and start practicing your way to success. Please do not forget to like this video also. It's very, very essential for the growth of this channel. Do not forget to subscribe. All right, so now let us continue. So this is what one of the substitution reaction. But what really happens, okay? What really happens? What really happens behind the scene when it comes to what this substitution is what we are now going to look at. Okay, I'm going to look at what to call free radical mechanism. There's something we call free radical mechanism. Okay, free radical mechanism. Okay, and in this mechanism we have 3 stages. We have the first stage we call the initiation stage. Then the next one we call what? The propagation stage. Then the third one is what we call the termination stage. Okay, so in this initiation stage, it's a stage, we also call it what? Homolytic fission. It's a very, very important stage. It's very important because this substitution reaction we're talking about now, we're trying to tell you what happens behind the scene. Okay, now free radical mechanism explains this. Okay, you have 3 stages. Initiation stage, the stage of homolytic fission. That's where the reaction begins. For example, if you have a chlorine molecule, Cl2, okay, and of course, if you want to break this chlorine molecule into radical, that means that we are going to both radicals are going to be having unpaired electrons. All right. So, for example, if you have Cl2 broken down into 2Cl radical, we put a dot at the front of this radical to denote that they have unpaired electrons. Okay, so you said that it says Cl2 broken down into Cl radical plus Cl radical, or Cl2 to give us 2Cl radical. So this is this molecule that has been broken down into Cl radical and Cl radical. Okay, so now this is the first stage. Okay, lytic means breaking. You know what fission means now, right? So for example, we have done nuclear fission, so you already have an idea what fission will mean. All right, so now we have broken down this molecule in the initiation stage to give us chlorine radical and chlorine radical, 2 chlorine radical. Now in this radical form, this chlorine radical, they are very, very, very reactive. In fact, they are, I don't know the word I should use. Okay, you know when an animal is on heat, right? That it want to just looking for another any animal to mate with. Even if the animal is not of its same species with it. So that is what happens when they are in this radical form. Okay, they are very, very reactive in this form. In this radical form, they can react with anything. And the alkanes, The alkanes, they are not so all that reactive. So because they are not all that reactive, but because of the reactivity of what, of course, how reactive this chlorine radical is, they can react with anything. So even with the alkanes that are not what, that do not like going into reactions, so they can react with the alkanes to now give us what, another what, radical. So now for the initiation stage, the chlorine molecule is broken into chlorine what, 2 chlorine radicals. Then in the next stage now, which is the propagation stage, okay, the propagation stage, we're now going to see, for example, methane, which is CH4, now reacting with what, with one of the chlorine radical here plus Cl radical. So if it does this, we're now going to have what now? We're going to have HCl plus CH3 radical again. Okay, so this is what happens. All right, when what, a methane or an alkane reacts with this chlorine radical, will form hydrochloric acid, and another radical is formed again. So we form another radical in the propagation stage. All right, and this radical also can also react again with chlorine molecule to give us another radical, another chlorine radical again. Let us see that. So we're going to have that CH3 radical can also react with chlorine molecule Cl2 to now give us CH3Cl, okay, then plus what now? Cl dot again, okay. So now another radical is formed, okay. So we can continue this process forever, okay, and we'll keep forming more radicals, but that now leads us to the last stage, which we call the termination stage. In this termination stage, what happens is that what, 2 radicals that have unpaired electrons collide, and when they collide, we do not form what, radicals again, okay. So that means this CH3 can react with what, this CH3 radical can react with this Cl radical to now give us what, CH3Cl, okay. So that is now the termination stage. So I'm going to have CH3 radical plus Cl radical to give us CH3Cl. It's no longer what, a radical, okay, because 2 radicals that have unpaired electrons have collided will no longer what, have radical. So this is what will happen. This mechanism, this is what happens. But very importantly, as it pertains to that question we saw from the OTT school JAMB, which is a past question from JAMB, where we're going to see a very, very important reaction, halogenation. Halogenation reaction between what, methane and chlorine to give us what, tetrachloride. I told you it's a 4-step reaction, okay. From the beginning of the reaction, the first step of the reaction, CH4, okay, then plus now Cl2, okay. So I'm going to have what now? It's a substitution reaction. So because of that, from what we have seen from the previous reaction, one of the hydrogen atom here we leave here. So I'm going to, instead of CH4 here, in this product, I'm going to have what, CH3, then I'm going to have what, Cl, then plus what now? Plus HCl. This one is called what? Monochloromethane. This is monochloromethane. All right, I've seen that. It's very clear. Okay, then now the next stage is this monochloromethane now reacting with what? With chlorine again. Okay, remember this is methane. This is methane. All right, then the next stage is what? Monochloromethane, CH3Cl reacting with what? Cl2 again. And when this happens, this one will have what? 1 hydrogen atom less. I'm going to have CH3, not CH3 any longer, CH2, Cl2, all right, then plus what? HCl. You know why it's CH2Cl2, right? Because there's a Cl here before. So it's only 1 hydrogen atom we are removing. So that Cl plus this Cl that's coming here will be Cl2, okay? That's why I have CH2, Cl2 plus what? HCl. This one is called dichloromethane. All right, this is what? Hydrochloric acid. Why this one is what now? Monochloromethane. Monochloromethane. Now, that is that. Then now the third stage is what? This dichloromethane reacting with chlorine again. So I'm going to have CH2, Cl2 plus Cl2. Okay, so this will now give us what now? CH, 1 hydrogen atom less. Then Cl3 now, Cl3, then plus what? HCl. All right. So this is the third stage of what? Of the reaction. We're going to have what? CHCl3 plus HCl. This is called what? Trichloromethane. Trichloromethane. It's also called chloroform. All right, so this is the formula for what? For chloroform. Take note of that. This is what? Trichlorometane or chloroform. That is the third stage of the reaction. Now, for the last and final stage, it is this what? Chloroform reacting with what now? With this what? Dichloromethane. Okay, remember this is dichloromethane. All right, so now for the last stage, we're going to have what? CHCl3, then plus what now? Cl2. Okay, so this will give us what now? So I'm going to have what? C, one hydrogen atom less. So that means I'm not going to have hydrogen here again. I'm going to have C. Then one chlorine atom is coming to join these 3 chlorine atoms already here. So that's what now? Cl4. Then plus what? HCl. Okay, so this is what called what? Carbon tetrachloride. Carbon tetrachloride. All right, so that is what the final what step. Okay, it's a 4-step reaction where we'll maintain react with chlorine to give us what? Carbon tetrachloride. It's not just happen once. Okay, this happens. This first of all forms monochloromethane. It now gives us dichloromethane, trichloromethane up to what? Tetrachloride. Okay, and remember that this reaction, if you write this reaction for me as a teacher, I will give you 0. Okay, so you must tell me the condition that's what this reaction is occurring or is happening, and it is in the presence of what? Of diffuse sunlight. In the presence of what? Of diffuse sunlight. So I'm going to shorten this to DS. So in presence of diffuse sunlight, you don't shorten it to anybody. Make sure you write it as full. Diffuse was sunlight. Okay, so please, that is that. This is the reaction. It's a very, very, very important reaction. Okay, most of the products that are formed, they are used as what? As solvents. Okay, they are used as what? As solvents. All right. So please let us now go to the final reactions that alkanes undergo. We are going to look at is nitration. All right, nitration. Nitration simply is the addition of a nitro group. Okay, it's simply the addition of a nitro group. Okay, so the last reaction I'm going to look at is nitration. Okay, and I say it's what? Addition of a nitro group. Okay, so this reaction can only occur under some certain condition. One of the conditions is that the temperature of the reaction must be from 450 degrees Celsius to 500 degrees Celsius. It should not be what? Less than. Okay, or it should not be more than. Okay, it must occur within this temperature. All right, then likewise, second condition is that HNO3 must be used as the reagent. Okay, that's what HNO3 must be used as the reagent. That is the other condition for this reaction to occur. Okay, then of course we can now continue. All right, so firstly now let's say maintain. Okay, reacting with, for example, with HNO3. This is the reagent that is used. The temperature here is what? 450 degrees Celsius. All right, okay. So what I'm going to have? I'm going to have what? CH3NO2 plus what? Plus H2O. This will be our product. Okay. Then, for example, let's say ethane, C2H6 plus HNO3. Okay. At the same temperature, 450 degrees Celsius, it will now give us what now? C2. Okay. I'm going to have what now? H5NO2 plus what? H2O. Okay, so this is what? Nitration. All right, most of these are products that are formed. These products that are formed, important to note here that these products that are formed, they can be used as what? Solvents or as fuels. Okay, can be used as solvents or as fuels. So please, let's go to the app and answer some questions, and then we are done with this class. All right, and also don't forget to like this video, don't forget to subscribe to this channel, and do not forget to keep sharing our videos to your friends and loved ones. 1995, number 42. The reaction that we're giving, the question is being displayed on the screen. They say the reaction is an example of, obviously, that is what? A substitution reaction. It's a substitution reaction. Let us see 2004, number 24. 2004 JAMB question. Imagine I say we already answered JAMB question. 2004, number 24. They said, a characteristics of the alkane family is A, substitution reaction, B, neutralization reaction, C, addition reaction, D, elimination reaction. What should be our final answer there? Our answer there will be what? A, substitution reaction. It's a characteristic of the alkane family. So please jump on this application, download it, activate it. I know what I'm telling you. If it were not so, I will have told you. Please, I'll see you in the next class. I remain your commander of this great army. See you at the top. Thank you for watching.